Okay, now we're going to get into how do we solve equations that have trigonometry in them. Solving trig equations. That's a G, sorry there. Alright, so we're just going to jump right into it, and we're going to basically use the unit circle in reverse as our first kind of strategy. So if we're trying to solve the sine of x equals root 3 over 2, we're looking for what angle has a sine value of root 3 over 2. So if I think of my unit circle, I know root 3 over 2 is the long number, the biggest number. And I know that the sine value is the y value. So if I think of my circle here, I know that the root 3 over 2, that's going to have that big sine value there. So that means what angle is that going to be? That's going to be our 60-degree angle. So I'm going to say that x is going to be equal to pi over 3 radians. Now that's not the only angle that has that sine value of root 3 over 2. We also have this angle here, which is going to be 120 or 2 pi over 3. Then we also have this one here. That's going to have this big y value as well, root 3 over 2, but it's negative, so that is not a choice. Then we also have this one down here, and it's also negative. So this will be our negative root 3 over 2. This one's negative root 3 over 2. So we're not going to use those angles, but we can keep going around. So once I get back to, so when I go around once and I get back to 2 pi, I'm going to keep going. So then if I go another 60 degrees, I'll be back at this angle. So that's going to be, let's see, 1, 2, 3, 4, 6, 7 pi over 3. And then again here, that's going to be 8 pi over 3. And I can just keep going around and around. And so what happens is, really there's like two sets of things going. If I take pi over 3 and I add 2 pi to it, I get 7 pi over 3. Because that means I just went around the circle one full time and arrived back here. I could do the same thing with 2 pi over 3. If I add a full rotation onto it, right, that means I'm here. If I add a full rotation of 2 pi, I'm back here again, and that's how I get the 8 pi over 3. And I can just keep doing this. It could go, this is getting messy, so I'm going to erase it. It can go on and on and on. So the answers are infinite. So usually what has to happen is somewhere in the directions or in the question stem, they're going to give you some restrictions. Like they might say something to the effect of what x has to be, or your angle has to be in between. So they might say, like, typically you'll see that it's got to be in between 0 and 2 pi. That'll tell you that they want it in radians. Or it might say between 0 and 360 degrees. All right, so we'll stick with degrees for the rest of this exercise, not radians. So I know I did this one in radians. So that means that the answer on that interval would just be these two guys. We don't add 2 pi because it'll go outside of our interval. All right, let's look at another example. We could have cotangent of x equals negative root 3. So what you want to know here is that we know our numbers, like for sine and cosine, right, are these guys. And we know tangent and cotangent is made up by dividing those. Now, for the root 2 over 2, tangent and cotangent is always going to be root 2 over 2 over root 2 over 2 itself. So that's going to work out to like a 1 or a negative 1. So we're going to watch out for those numbers for cotangent. But then these guys, if I combine root 3 over 2 and 1/2, the numbers we're going to get are either going to be root 3 over 3 or root 3. Depends on which fraction I make. So if I do the root 3 over 2, so let me get some room here. We want to recognize these numbers is my point. So if I do like the root 3 over 2 over 1/2, instead of dividing by 1/2, we multiply by 2, and that's going to give us our root 3. So we're going to watch out for tangents and cotangents that have root 3. And then if we're the other way around, if the 1/2 is on top, instead of dividing by that, we're going to multiply by 2 over root 3, and we'll get 1 over root 3, and then we have to rationalize, and we'll get root 3 over 3. So we're going to watch out for those numbers as well. So when I see this negative root 3, I know that that's one of our angles that we know, like one of our reference angles, our 30, 60 ones, right? We know it's not the 45. So how do we figure that out? You can remember these numbers and what their values are. I think cotangent is cosine over sine. And if I'm ending up with root 3, that's the one where the root 3 over 2 is on top and the 1/2 is on the bottom. Now, if it's coming out negative, either one of those can be negative. The top can be negative or the bottom can be negative. So we'll start deciding quadrants in a second. First, we want to figure out which angle has a cosine value of root 3 over 2. So that's the long side, and then sine is 1/2. That's the short side. So that's going to be our 30-degree reference angle on our unit circle. Because if I look at this low flat angle, this is going to be, the x is going to be root 3 over 2, and the sine or the y is going to be 1/2. And that's what's going to lead to the root 3. All right, so now in quadrant 1, our cotangent is going to be positive, right? Because it's all students take calculus. So cotangent is going to be negative in which quadrant? So if I come over here, cotangent will be negative because I'll have my negative root 3 over 2 and then my 1/2. If I go into quadrant 3, only tangent is negative, so that's no good. And then if I go into quadrant 4, that one is also going to be negative because my cosine's positive, but this time my sine is negative. So it's going to be quadrant 2 and quadrant 4. Okay? So it works in the sine quadrant where only the sine's positive or only the cosine's positive, because that means the other one's negative in those quadrants. So when you take a positive divided by a negative, you're going to get a negative. So it's going to be the 30-degree reference angle in both of those. So x is going to be 150 degrees. That's the 30-degree reference in quadrant 2. And then also 330 degrees. That's the reference angle in quadrant 4. Let's look at another one. So what we have to do here is, if you notice the difference from 1 and 2, those were already solved for the trig part. So the sine of x was equal to something. There was nothing else on the other side with the sine of x. On number 2, cotangent was already solved for. So here on number 3, we see cosine is not all by itself. So first we want to get cosine by itself. So what we're going to do here is divide both sides by -2. So on the left side, this is 1. So then I get cosine of x equals negative root 3 over 2. So again, we think of our unit circle. Where's the cosine going to be negative? Where's cosine going to be root 3 over 2? That's that low flat angle because we have the big cosine value because root 3 over 2 is the big number. So that's going to be negative. Cosine is going to be negative when we go this way, right? So that means when I go up or down from 180, both of those will be the negative cosine angles with a reference angle of 30. So it's going to be the 180 minus the 30, so 150. And then we're going to go 30 past 180, so it's going to be 210. Okay, we're going to keep kind of making these a little harder as we go. And mostly what I mean by harder is like just the setup to get to this, what we have to do to get to the cosine solved by itself. And then solving it is just the same thing over and over. So our example number 4, we're going to go with 5 sine of x equals 3 sine of x minus 1. So again, we want to get sine x equals or cosine x equals. So I see like I have 5 sine x's equals 3 sine x's minus 1. So I can subtract 3 sine x's off of both sides. So the sine of x, it's almost like a variable. If you had 5x equals 3x, right? If these were giant x's, how would you solve it? You would start by subtracting 3x, okay? So That's how you kind of think of this. So on the right side, 5 sine minus 3 sine is going to give me 2 sine of x. These over here cancel, so I get negative 1. So I want to get sine x by itself. So I'm going to divide by 2 on both sides. And I'll get sine of x equals negative 1/2 because those are equal to 1, so they cancel. So I'm looking for a sine, an angle whose sine value is negative 1/2. So sine value of 1/2, 1/2 is the small number and sine is the y. So again, we're dealing with this 30-degree reference angle because that's got the sine value of 1/2. Now these are positive 1/2 when I put my y values going up. So I want the negative 1/2, so it's when they go down here. So it's going to be this triangle here will be negative 1/2 for a sine, and this triangle here. So we're going to go to 180 plus another 30 here, so that's going to be 210 degrees. And then this is 30 degrees before we get to 360, so it's going to be 330 degrees. Those are our two solutions, remember, on this given interval, that your angle has to be between 0 and 360. And notice that it can be equal to 0, but it doesn't have to be equal, or it can't be equal to 360. All right, let's look at our next equation. What else can we do here? We can say, what if we have tangent of x plus cosine of x times tangent of x equals 0. How do we solve something like this? It's got two trig things in it now. It's not just sine or just cosine or just like secant or cotangent. This is what we had going on all of these. We could get sine by itself. We can get cosine by itself. But now I've got two trig values here, two trig expressions. So what we want to do is we want to get this thing factored and apply our zero product property. If I could write it as a bunch of things times each other equaling 0, think back to algebra, we had something like this. If we had this, we knew that each one, x plus 1 can equal 0, x minus 3 can equal 0 because of the zero product property. If I have 4 things times each other, if I make it multiplication, if any one of them is 0, then the whole thing equals 0, and that's what we want. So we want to write this thing in factored form to make it into multiplication. It doesn't work when there's addition here. I can't solve equal to 0 because the zero product property doesn't apply. The left side is not a product. So I want to make it a product. So we worked on factoring a lot in algebra. So I can factor a tangent x out of both of these terms. There's two terms separated by the addition. So if I divide a tangent x out of the first term, I get a 1. If I divide a tangent x out of the second term, I'm left with cosine of x. Now I've got it as a product, the left side, right? I've got two things times each other. I've got tangent times this stuff equaling 0. So solutions will be whenever either one equals 0. So we have two little mini equations now that we can solve. So tangent of x, when does that equal 0? Well, tangent is equal to sine over cosine. So this will equal 0 when the top equals 0. So I want sine x equal to 0. That will be my solutions. So when is sine of x equal to 0? It's going to be 0. Pi over 2 is sine is 1. Sorry, we're doing degrees. 90 is 1. 180, sine is 0 again. And then that's it before we get back to 360. But 360, as we said, is not included up here in the directions. So we don't include the 360 in our answer. So that's some of the answers from when tangent equals 0. Now we got to check when cosine, 1 plus cosine equals 0. So I'm going to use the same methods I've used before. I want to get the cosine by itself. So I'm going to subtract 1 off both sides of this equation, and we arrive here. So now when is cosine equal to negative 1? That's going to be at 180 degrees, and that is it. So there are my solutions. Oh, and 180 was already a solution to the other side. So really, maybe I don't want to circle my answers until the end. I'll say, so the final answer is x equals 0 and 180 degrees. I don't have to list the 180 twice. Let's look at another example. What if one's already factored? This looks like it was maybe a difference of 2 squares. That's why I want to show you this one. All right, this one's already factored, so it's what we just did. So I can say sine of x plus 1 equals 0 by the zero product property, or sine of x minus 1 equals 0 by the zero product property, because if I have two things times each other equaling 0, my solutions is where one or the other one is equal to 0. So I've got sine of x equals negative 1 and sine of x equals positive 1. When is sine of x equal to negative 1? That's when x is 270 degrees. When is sine of x equal to 1? That's going to be when x is 90 degrees. So our solutions are 90 degrees and 270 degrees. This one, keep in mind, it's already factored, but I just wanted to show you that it may have come from this. Maybe that would have been the original, and you have to recognize this as a difference of 2 squares, like if you saw x squared minus 1 equals 0. This is the same thing, but instead of x squared, you have sine squared. Let's look at 7, our example number 7. Where did I write this down? 2 cosine squared of x minus cosine of x minus 1 equals 0. So usually the first time I show this, I do what's called a u substitution. Keep in mind that this means 2 times cosine, whoops, that's not what I wanted to do. 2 times cosine of x squared. That's what cosine squared means. So what I usually show is a u substitution here, and we'll do it the first time. I'm going to say u equals to cosine of x, and then I'm going to rewrite this thing. So I have 2. Instead of cosine of x, I plug in a u. Instead of a cosine of x, I plug in a u. Sometimes it makes it easier to see how you factor this. So this goes back to our factoring of trinomials. So I know it's going to be 2u and u. And now we're looking for other combinations. We could split the middle term if you like. I like to just check combinations. So I know it's going to be 1 and 1. I'm going to say that that's plus and that's minus. So I multiply it back out to check it. I know the first times the first equals and the last times the last works, so I'm just checking the combination in the middle of those two. So I get negative 2u plus u is negative u. So it's good. Now what we want to do is, we did the u substitution to factor. Now we can plug our u's back in. U is really cosine of x. So I have 2 cosine of x plus 1 times cosine of x minus 1. So we don't need to do the u substitution. I'm just saying instead of cosine, I can put u's here to make it a little easier to see the factoring. As we move forward, we're probably not going to do this again. We don't need to do a u substitution. Right? We can just factor. We could probably go from here straight to here without having to plug in u's. I just like to show that so you can see that it's really just factoring a trinomial. Now that I have it factored, I use the zero product property, which says it can make the first factor equal 0 or the second factor equal 0, and solve those. So now I'm back to just getting this cosine by itself. So I'm going to go cosine of x. If I subtract 1 and divide by 2, I'll get cosine of x equals negative 1/2. So where is cosine negative 1/2? I'm not going to draw the picture for you. You should pause the video here and see if you can figure this out without me. Okay, welcome back. So cosine is the angle where cosine is negative 1/2 is going to happen at 120 degrees and also 240 degrees. All right, and then we're going to do one last example here. Oh, sorry, I didn't solve this other side. I also have to do this. Cosine of x equals 1. That occurs at x equals 0. And then again at 360, but 360 is not in our solution set. So again, I shouldn't really box these until I've done both. The final answer is 0 degrees, 120 degrees, 240 degrees. Number 8 is going to be sine squared of x minus 1 equals 0. So we're going to factor this guy into sine of x plus 1 and sine of x minus 1 equals 0. And then it becomes, it's the same thing as number 6. Okay, I just wanted to show you that. It's a difference of two squares. We factor it, and then we would finish it like number 6. There's other things that might come up. So I'm not going to do every last example you could see. You have to have some skills for solving equations, and this just gives you an idea of some of the things you can do. We'll talk about the other stuff in class as they come up.